Today we practiced putting numbers in scientific notation. And when we see a number like 32 billion written here, there's some things that we have to remember. The first thing I need to do is to place the decimal between the 3 and the 2 to achieve a value that is greater than 1 and smaller than 10. I need to recognize that my decimal point is at the end of this number, and I need to move it between the 3 and the 2. So that will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spots. So I have moved the decimal point 10 places. So when I write my number in scientific notation, I write the decimal as 3.2. I'm always multiplying by 10. And because I moved the decimal place 10, or decimal point 10 places, my exponent will be 10. Now, before we move on, we need to make sure that this makes sense. I have a very large number, okay, very large number. And as we said in class, a very large number is going to have a positive exponent when written in scientific notation. The next problem that you may encounter is one where we have to add or subtract numbers written in scientific notation. Now, the nice thing about scientific notation is if my exponents are the same, then all I have to do is add the decimals out front and keep the same power of 10. However, as you can see, we have a 7 and we have a 9, so that's not going to work. So how can we address this change? What can we do differently? Well, if you remember earlier in the lessons on laws of exponents, another way I could write 10 to the 9th power would be 10 to the 2 plus 7, okay? And another way that I can write 10 to the 2 plus 7 would be 10 to the 2nd power times 10 to the 7th power, okay? So once again, we know that these are equal because if I have the same bases and I'm multiplying, I'm able just to add the exponents. 10 to the 2 plus 7 equals 10 to the 9th power. So now that I know that 10 to the 9th power equals 10 to the 2 plus 7, I can rewrite my problem. So I'm going to have 5.4 times 10 to the 7th, and I'm going to add 8.24 times, and instead of 10 to the 9th, I'm going to write 10 to the 2nd times 10 to the 7th. Well, we all know that 10 to the 2nd is 100, right? This equals 100. So if I do 8.24 times 100, it would be like moving my decimal point twice. So I can now rewrite this as 5.4 times 10 to the 7th plus 824 times 10 to the 7th. Now that my exponents are the same, 7 and 7, I simply add the numbers out front. So I have 5.4 plus 824. Sorry, the decimal place previously was in the wrong place. It should be here. 824, and all of that times 10 to the 7th. Well, 824 plus 5.4 would give me 829.4 times 10 to the 7th. Now, if they want us to write this in scientific notation, now we have to realize that 829 is not between 1 and 10. So we would need to move this decimal point over twice. And if I have to move that over twice, then I need to change this to a 9. Okay, so we would have 8.294 times 10 to the 9th power would be the sum of 5.4 times 10 to the 7th and 8.24 times 10 to the 9th. Now, this does make sense because we would not expect to add two numbers and end up with a number that's smaller than what we started unless they were negative. So, the one other way that we can handle this problem would be if you have a calculator that has an exponential feature on it. So what I would like to show you real quick is the calculators that we have, and maybe you could download an app or download a calculator. So let me show you how we can do it here. So if I have this calculator, all right, the EE button here, right here, stands for scientific notation. So I can do the same problem by doing 5.4 EE is like times 10 to the 7th power plus 8.24 EE9, and I press equals, and there it gives me my answer in standard form. And if I want to put that in scientific notation, I can hit the second function button and hit 5. And there we have 8.294 times 10 to the 9th power, which is in fact the same as what we had previously. So, thank you for watching this video. Hopefully it was helpful to you. If you have any further questions, just ask me in class tomorrow.